Let's look at OpenStax University Physics Volume 2, Chapter 12, Problem 33. A circuit with current I has two long parallel wire sections that carry current in opposite directions. Find magnetic fields at a point P near these wires that is a distance A from one wire and B from the other wire as shown in the figure. So things that we know are current I, this one is coming out of the page, and this one is going into the page. So it's the same current but in opposite directions, and then this distance is A and that distance is B. So we basically know that we have an I going out, we have an I going in, an A and a B, and we're looking for the net magnetic field at point P. So I already drew these circles here, and they are the direction of the magnetic field for each of the wires. So if you place your thumb in the direction of this current, so it should be coming out of this page, then the hand will circle around the thumb in this direction. So that means that at point P, the magnetic field will be tangential to the circle and pointing in that direction because the magnetic field was in this direction here. So I'll call this B1. Then if we point our thumb in the direction going into the paper, then the magnetic field will circle around in this direction, in the direction of our fingers. So there will be a magnetic field going this way through this orange loop. So tangential at point P will be this way. So that would be magnetic field due to the wire that goes into this paper. So now we can write down what those magnetic fields are. So I know that B1 is mu naught I divided by 2 pi times the distance from here to there, and that is just A. Then B2 is mu naught I divided by 2 pi times the distance from the current to this point, so that is B. Now we notice that the magnetic fields are not in the same direction, so I'm going to pick my positive y-axis going up and my positive x-axis going to the right, so that's my plus x and plus y. I notice that B2 is in the positive x direction, but B1 has a component in the y direction and one in the negative x direction, so I'll have B1 y going this way and B1 x going that way. So now if I try to find Bx, B net x, that is B2 minus B1x. So now I need an angle. So let's say that I'm calling this angle here theta. That makes this angle here theta. So this will become B2 minus B1 sine theta. Then in the y direction, we have By is just B1y, and that will be B1 cosine theta. So let's start writing things out. So I know then that sine theta, so from here, sine theta is B divided by A. Cosine theta is adjacent divided by hypotenuse. So that means that we have square root a squared minus b squared divided by a as cosine theta. So let's start putting things together. Bx will be b2, so that's mu naught I divided by 2 pi b, minus b1, so that's mu naught I divided by 2 pi a, times sine theta, b over a. So bx will be mu naught I divided by 2 pi, so I factor that out, times a squared minus b squared divided by a squared b. By will be mu naught I divided by 2 pi times square root a squared minus b squared divided by a squared. So now we have the x and y components of the magnetic field. That means that B net is square root bx squared plus by squared. And when we do the math, we end up with a value of mu naught I divided by 2 pi a b square root a squared minus b squared. I'm not going to do all this derivation, but do it by yourselves and you'll see that this is the answer that you'll come up with. Then we need the angle of the magnetic field. So the angle with respect to the x-axis will be the inverse tangent of by divided by bx, and that is inverse tangent of b divided by square root a squared minus b squared. So this is the direction of the magnetic field.